today's video, I will try to discuss some real-life problems involving trigonometric ratios. But for this content of the video, I would like to emphasize that I will be focusing more on the trigonometry in game development. In fact, trigonometry is widely used in game development to ensure the game's functionality. It is used in the creation of game programs that allow objects to move. It is also used to create objects, characters, and sets. When programming a game, the positions and speeds of objects must be written in x and y coordinates. Triangles are used to determine the position and speeds of objects. As a result, trigonometry must be used to calculate x and y values, which must then be coded. This includes moving an object at a specific speed, and turning an object. In moving an object, assume you're creating a spaceship game and you decide to relocate the ship to the red X. We know the radius of the circle and the number of degrees we want to travel around it. The X and Y coordinates are required when programming. So to find X, we can use trigonometric ratio for sine angle A is equal to X all over the radius. We can also manipulate the equation so that sine of angle A times the radius is equal to X. And on the other hand, we can also find Y by the use of the trigonometric ratio for cosine. So cosine of A is equal to Y over the radius, and we can also manipulate that as shown in this illustration. And provided here is the link so that you can try out to put in the code when you want to move an object when programming a game. I would like to demonstrate the use of trigonometry when moving an object in game programming. So let's say for example we wanted to move Koopa to this red dot in here. Therefore, we need the radius from the illustration, which is 8 meters, and the angle, which is 47 degrees, for us to be able to identify the x and y values. So we have here an angle which is 47 degrees, an opposite side which is labeled as x, and then an adjacent side which is y, together with the hypotenuse or the radius which is 8 meters in length. Now, so in our solution, since we have the following, we'll be able to identify the value of x and y by the use of the sine and cosine. So we will be using the acronym SO and K to identify the two missing values in here, which are x and y. So let's start first with x. X is opposite 47 degrees, and we need the hypotenuse. We have here the opposite side and the hypotenuse, so that is sine 47 degrees with the opposite side, so that is x, and together with the hypotenuse, which is 8. Now to solve for x, we need to multiply both sides by 8, so that 8 will cancel out on the right side, and we are left with x. So that will become 8 times sine 47 degrees is equal to x. So to find the value of x, we need a calculator for that. So let us show that by using a calculator. So to find x, we need to multiply 8 together with the sine of 47 degrees. So our final answer will be 5.85083. X is approximately equal to 5.85083. Now, rounding this off to the nearest tenths, that will be 5.9 meters. So that is the value of x. Now, if we are going to proceed and look for the value of y, we'll be then using K, or the acronym K for cosine, which means we need the adjacent side, which is y, and together with the hypotenuse, which is 8. So let us show that in our solution. So that is still 47 degrees as our reference angle. So basically that is cosine of 47 degrees is equal to the adjacent side, which is y, and of course your hypotenuse, which is 8. And then to get rid of 8 on the right side, we need to multiply both sides by 8 so that 8 will cancel out. And then we are left with y on the right side. And this will become 8 times cosine of 47 degrees. So if we are going to solve that by the use of a calculator, so 8 times the cosine of 47 degrees will be 5.45599. So that is 5.45599. Y is approximately equal to 5.5. So here you go. The values of x and y are the following. X will be approximately equal to 5.9 and y will be approximately equal to 5.5. Thank you so much for watching and see you on the next videos.